Assalamualaikum and good day to all. My name is Nur Zafira binti Muhammad and I'm from University Tun Hussein of Malaysia. I am currently student of Bachelor of Applied Physics in 3rd year. Now I will present my research proposal entitled Preparation and Characterization of Watermelon Rind to Treat Wastewater. Activated carbon, AC, is a carbonaceous material generated by thermal or thermochemical process from coal, biomass, or fruit peels. ACs are characterized by their well-developed pore shape, astoundingly large surface area, electron conducting amphoteric tendencies, and great absorption capacity. Beyond absorption, AC is widely employed in numerous applications to treat diverse industrial effluents. Activated carbon is versatile absorbent material with a high porosity and surface area, and it can contain up to 90% of carbon. Wastewatermelon rind, a waste biomaterial, has not yet been evaluated as a raw material for the production of activated carbon using activation method by zinc chloride. Thus, the main objective of the present work was to evaluate the utility of wastewatermelon rind as an abundant and accessible precursor for activated carbon production. One of the problem statements in my study is the water supply is become progressively polluted as a result of rapid growth of industry. Aquatic life is progressively being harmed as a result of industrial contaminants entering the water system. When industrial wastes are dumped without being adequately handled, the water becomes increasingly poisonous, making it impossible for humans to treat and utilize it. Because of this problem, removing and reducing wastewater dye and heavy metal content is necessity if the aquatic ecology want to survive. Next, majority of fruits, just the pulps are consumed, leaving the seeds and the rinds behind. Consequently, discarding these rinds can have severe environmental consequences that have proven extremely challenging to address. Therefore, research into the nutritional and industrial possibilities of fruit waste must be expanded. Since watermelon is not a seasonal fruit, restaurant, fruit juice manufacturer, and food company in most states in Malaysia generated watermelon rind as one of several undesired leftovers. A substantial amount of this garbage is disposed of carelessly into environment, producing pollution in some way. In this study, the objectives are to analyze suitable acid for activated carbon process. Second, to study an absorbent from watermelon rind for wastewater treatment. And finally, to determine the optimal condition, which is temperature and time, to treat contaminated waste from watermelon rind. Methodology for this study. First, preparation of activated carbon. Raw material of watermelon peels will be collected from nearby market at Pago or Muar. At the same time, wastewater also will be collected from there. The peels then soak and wash in distilled water to remove the impurities. Then the rind will be sun-dried for several days, can up to 7 days, to reduce the moisture. The dried rind then will be crushed into powder and will be separated into several parts for carbonization process. For the first part, the 3 samples undergo carbonization process at different temperature but at the same time. The time will be used around 15 to 30 minutes. The second part, the sample undergo the different time but same temperature. Then Both part of the sample will be cooled down in open air for around 1 hour or until it cools. Then the cool sample ground into fine powder. The powder then goes under milling to reduce the particle size. The sample will be sieved into fine powder to increase the surface morphology. For the characterization of activated carbon, I will be use scanning electron microscopy (SEM) and Fourier transform infrared spectrometer (FTIR). The activated carbon process then start with to activate the carbon, then we'll start with zinc chloride with concentration of 0.5 mol and 1.0 mol, 1.5 mol, and 2.0 mol. For each process, the pH and percent reduction of contaminated will be recorded. The same step will be repeated for sulfuric acid and hydrochloric acid with the same concentration for each acid.